Hello, my name is Tanzania.
My name is Nur Kratain Akila.
My name is Tasha Jason.
My name is Muhammad Azri.
We are from
Group Newton.
We are from Group Newton.
We would like to
talk about
Speed of light.
In the 1600s, Galileo reputedly tried to measure the speed of light. He stood on a hilltop with a lantern, while his assistant stood on another hilltop with another lantern. The plan was that Galileo would open his lantern, and when his assistant saw the light, he would uncover his lantern. Then, Galileo would measure the time between when he first uncovered his lantern and when he saw the light from his assistant. But the speed of light is so fast, and the distance between Galileo and his assistant so relatively short, that they soon realized this experiment could only measure their reaction times and not the speed of light.
Two spaceships are traveling together through the galaxy at close to the speed of light. Mounted on one ship is a laser that can fire pulses of light. And on the other, a mirror. The pilot of the first ship fires a pulse at the mirror and watches as it is reflected back. A clock on board measures how long the round trip takes. But now suppose that he does this as the ships are passing an observer on a nearby asteroid. According to relativity theory, this observer sees the pulse moving through space at exactly the same speed that the pilot does, namely the speed of light. But he also sees the pulse traveling a longer distance, because from his perspective, he must add the forward motion of the ships to the motion of the pulse between them. So he measures a longer time interval for this round trip than the pilot does, because he's watching the pulse go farther without going any faster. This effect is called time dilation. If two observers are moving with respect to one another, each perceives that the other's time is flowing more slowly.
We all know that light bends when it travels through glass, water, or other transparent material. That's how a microscope, lighthouse, and spectacles all work. And you might even know that light bends because it travels slower through glass or water than through air. But why does light slow down? And how does it speed up again when it comes out on the other side? There's nothing there to give it a push. Well, if you think light is a wave, it's easy to explain. Electromagnetic waves simply travel slower through glass than through air. So the wave crests are closer to each other, but the light still oscillates the same number of times per second. It stays the same color. When the wave hits the air again, its color still doesn't change, while the crests spread out and it returns to light speed. The simplified explanation is that the energy of a wave is determined by its frequency or color, which doesn't change. So it doesn't need a boost to speed up at the other side. But wait, you say, I thought light traveled at the same speed in every reference frame. You still haven't explained how it can slow down. Well, now let's think about light as a particle. When light goes through glass, it gets knocked around and bumps into all sorts of molecules and electrons. So whenever it's traveling at the speed of light. But it's busy interacting with and scattering off lots of stuff along the way, and it doesn't necessarily take the shortest path through the glass. It's like the President of the United States trying to cross a room. If the room is empty, he can walk across directly. But if the room is full of people, all of whom want to shake the president's hand, even though he walks from person to person at full presidential speed, he'll get slowed down along the way. As soon as he reaches the far side of the room, though, he's free to resume his pace.